All right, Algebra 2, today, Lesson 12. We're going to talk about something that's extremely important called scatter plots. We'll have to do some work with our graphing calculators when you get to class tomorrow, but it'll be great, okay? So make sure you bring them. A scatter plot is an informative way to display numerical data with two variables. In your previous work, not necessarily in grade 8, you saw how to construct and interpret scatter plots. So just like normal, I'm not sure where each of you are coming from as far as what you knew before you got to my class. So we're going to review it. Recall that if the two numerical variables are denoted by x and y, the scatter plot data is the plot of the xy data pairs. So we have the x-axis and the y-axis, right? So example 1, looking for patterns in a scatter plot. A national climate data center collects data on weather conditions at various locations. They classify each day as clear, partly cloudy, or cloudy. Using data taken over a number of years, they provide data on the following variables. So x represents the elevation above sea level, y represents the mean number of clear days per year, w represents the mean number of partly cloudy days per year, and z represents the mean number of cloudy days per year. So we've got x, elevation above sea level, and then lots of different other variables. So we have x, and then w, y, w, and z. So here's a scatter plot of the data on elevation and the mean number of clear days. If you look, the mean number of clear days, that was y in our chart. So we just graphed x and y. That gives us a scatter plot. Scatter plot, if you think it's just everything scattered. And what we're going to do with a scatter plot is look for a pattern, look for what it looks like. Is it linear? Is it parabolic? Is it cubic? Is it exponential, etc.? So first question says, do you see a pattern in the scatter plot, or does the data does it look like the data points are scattered? I didn't see a strong pattern. Looking at it again, you've got it there in front of you. A strong pattern would be when you're looking at it and we see a line, or when you're looking at it and you see a parabola, etc. So that would be a strong pattern that you would see, exponential. I don't see a strong pattern in this one, and again, that'll be probably opinion-based until we get to our calculator part where it'll tell us if there's a pattern or not, but I don't see one with this data. It looks pretty random to me. There might be slight elevation, a little bit linear, just really slight. So, yeah, not a strong pattern. How would you describe the relationship between the elevation and the mean number of clear days for these 14 cities? That is, does the mean number of clear days tend to increase as the elevation increases, or does the mean number of clear days tend to decrease? Slightly increase. Like if you're asking me to pick one, I'm going to say an increase. So as the elevation increases, the clear days increase. And then do you think that a straight line would be a good way to describe the relationship between the mean number of clear days and the elevation? It'd probably be your best bet. It's not a strong pattern, not strong. But if I had to pick one, I would stick with the linear, right? Right, so thinking about linear relationships, below are 3 scatter plots. Each one represents a data set with 8 observations. The scales on the x and y axis have been left off these plots on purpose. You have to think carefully about the relationships. So if you look, just trying to find the pattern, Okay, looks like I'm increasing linearly, decreasing linearly, and who knows with scatter plot 3. So let's look at these scatter plots and answer some questions. If one of these scatter plots represents the relationship between height and weight for 8 adults, which scatter plot do you think it is and why? If one of these scatter plots represents, so if I look at scatter plot 1, going back to look, if I look at scatter plot 1, let's see, we could do weight or height assigned to either axis. So as height increases, so does weight. And then if I looked at scatter plot 3, weight or height could be assigned to either axis again, weight or height assigned to either axis again, and there's no relationship. Handwriting's getting a little rough there, sorry. If one of these scatter plots represents a relationship between height and SAT math score for 8 high school seniors, which scatter plot do you think it is and why? I'd say 3, because there is no relation between those two pieces. If one of the scatter plots represents the relationship between the weight of a car and fuel efficiency for 8 cars, which scatter plot do you think it is and why? If you look at 2, you could say the weight or the fuel efficiency could be assigned either axis. So as the weight increases, fuel efficiency would decrease. Number 7, which of these scatter plots does not appear to represent a linear relationship? 3 looks like it's a mess. I see no relationship, okay? Exercises 8 through 13. When a straight line provides a reasonable summary of the relationship between two numerical variables, we say that the two variables are linearly related, or that there is a linear relationship between the two variables. Take a look at the scatter plots below and answer the questions that follow. I've got scatter plot 1. Looks like we may be able to get a linear relationship, but let's go ahead and answer the questions. Is there a relationship between the number of cell phone calls and age, or does it look like the data points are scattered? There's a slight relationship, I think. If there's a relationship between the number of cell phone calls and age, does the relationship appear to be linear? So as age increases, the number of cell phone calls decreases. I think as time goes on, this is less valid. You think about grandma and grandpa, they don't use cell phones as much. I would disagree. I think grandma and grandpa use cell phones a lot, but that's all right. Okay, looking at this next one, I don't know, looks like that. But let's answer some questions and see. Is there a relationship between moisture content and frying time, or do the data points look scattered? I see a definite relationship. If there's a relationship between the moisture content and frying time, does the relationship look linear? It doesn't look linear to me. So as frying time increases, moisture content decreases. It doesn't look linear to me. It looks curved. Okay, scatter plot 3. That's what it looks like to me. Let's see what the book says. Looks like I have price in dollars and quality rating of something. Scatterplot 3 shows data for the prices of bike helmets and the quality ratings of the helmets, based on a scale that estimates helmet quality. Is there a relationship between quality rating and price, or are the data points scattered? That looks pretty scattered to me. If there is a relationship between quality rating and price for bike helmets, does the relationship appear to be linear? Since there is no relationship, then you can't say that it's linear, right? So if there's no relationship between quality and rating, quality rating and price, then it doesn't make any sense to say the relationship is either linear or not linear. So actually I'm going to erase that, because if there is no relationship, you can't say if it's linear or not, because there's no relationship. Okay, that was pretty awesome. A scatter plot can be used to investigate whether or not there is a relationship between two numerical variables. A relationship between two numerical variables can be described as linear or nonlinear. That was it. Pretty awesome. Good work. Sorry, calculator is going to be in the next lesson, not this one. Calculator. Next lesson. Can't spell today.